The hand is made up of 3 types of bones: carpals, metacarpals, and phalanges. There are 8 small carpal bones that make up the base of the hand. They are arranged in 2 rows, the proximal row and the distal row. These bones can be remembered by the mnemonic, so long to pinky, here comes the thumb. The names of these bones are scaphoid, lunate, trichotrium, pisiforum, hamate, capitate, trapezoid, and trapezium. These 2 rows of bones are united by ligaments and are responsible for the mobility and support of the hand. The next type of bones are the metacarpal bones. These are the elongated bones that make up the palm of your hand. The first metacarpal bone is at the base of the thumb and is unique from all other metacarpal bones because of its extreme mobility and separation. The second through 5th metacarpals are united together and form the palm of your hand. The 2nd and 3rd metacarpals are anchored in place and immobile, whereas the 4th and 5th metacarpals have limited motion. This motion can be noticed when you make a fist. Try it. You can slightly move these 2 metacarpals. The last type of bones in your hand are the phalanges. These are the bones in your fingers and thumb. In your fingers, there are 3 types of phalanges: distal, middle, and proximal. However, the thumb only has distal and proximal. An opposable thumb is the sole reason we can hold and lift objects. Phalanges are small, which allows for specific and intricate movement in the fingers. This control enables you to be able to perform everyday functions such as itching your nose, writing your name, and tying your shoes.
As Lindsay mentioned in the last video, there are 27 bones in the hand and wrist. 8 of them are up in the wrist, and the rest of them make up the palm and the fingers. Now, the 8 in the wrist, the carpals, are classified as short bones, and they're classified as such because they're small and kind of cuboidal shaped. The other bones in the hand are known as long bones. Now, these bones are small, however, they are longer than they are wide, which means that they're long bones. These metacarpals here make up the palm of the hand, and these make up the fingers and the thumb. Now, this here is the cartilage, and this is what makes it possible for a human to bend the fingers. These here are where the knuckles are, and that's where the top of the knuckles are, right near the palm. Those joints up there are the reason that it's possible to rotate and move your wrist. Because the hand is so often used, there are many issues and problems that can come along, especially with age. One major thing is arthritis. Now, you get this in virtually every joint in the body, but specifically in the hand, it is where this cartilage and these joints become inflamed, making it very painful to move the hand and the wrist. In addition, the 5 bones in the palm are very prone to stress fractures, and it's very easy to break the fingers and the thumb simply because they're small, long bones. In addition to this, it's very easy to dislocate a thumb or a wrist should one of the bones be dislocated from one of the joints.
All joint surfaces are covered with articular cartilage in the hand. This allows the hand to move without pain. There are different types of cartilage that are in the hand, and those are hyaline fibrocartilage and elastic cartilage. This cartilage is stiff but flexible, making it prime for weight bearing. All of the joints are called synovial joints, which means that they contain mucous membranes that help to lubricate the joints for easier movement. The main knuckle joints in the hand are called metacarpal phalangeal joints, or MCP joints for short. They connect the phalanges to the metacarpals, which are the fingers, to the palm of the hand, and they work like a hinge so that you can bend and straighten your fingers and your thumb. There are 3 phalanges in each finger, so there are 2 joints in each phalange. The first one, located here, is called the proximal IP joint. This is closest to the MCP joints. And then there's the distal IP joint, which is near the end of each finger. These work like hinges as well, allowing us to grasp things. All of this cartilage fits into one category. It is called articular cartilage. Articular cartilage is white, shiny, and rubbery, and it's found just about everywhere in the body that two bony surfaces move against one another, or articulate. You can see it on all sides. There are many similarities as well as many differences between human hands and primate hands. When one compares the bone structure, they both look very similar. When one looks closer, however, one can notice that the thumb is slightly shorter on primates than the human thumb, and the rest of the fingers are longer than human fingers. This makes it easier for primates to be able to grasp trees and swing, while humans have an easier time with precision grasping. Because of these features in the bone structure, some scientists believe that the hands of primates are really more advanced than the hands of humans. Another astounding feature of the hand of a primate is that it's very versatile, just like a human hand. Primates are able to swing from trees, peel fruits, and even use their hands as feet. Primates are known to palm walk, using their front hands as feet, or knuckle walk. Another main difference in the function of primate hands to human hands is that primate hands have considerably more creases than the human hands do. This shows that primates use their hands in different ways than humans do, and shows that the way that they manipulate objects is different than how we do. One more similarity is that we both have tons of articular cartilage, aiding our fingers in bending and acting as hinges, allowing both hands to manipulate.